As I was saying, the S in IoT stand for security, which literally means there is no security whatsoever.
Part of the problem is there's a lot of mischaracterization around the concept of IoT and also embedded security. So you have to sort of step back and think of it as a distribution of devices. So the complexity of those devices can be extremely high or extremely small. So you can go down to like a pacemaker all the way up to a network router, and they're all devices at the edge of the network. Part of the problem that you get into, though, is that you can't get rid of all bugs. And Turing proved that in any reasonably complex software system, bugs will exist, and those will be exploited. So the characterization that you get to is essentially when you're looking at the edge of the network, there's a lot of problems. One is that you've got to be able to move data from the edge of the network to the core of the network. So where are you going to process it? You either process at the edge, somewhere closer to the edge to reduce the cost, or you backhaul it all the way to the central processing in the cloud. And one of the characteristics of that is that you're moving data. And as soon as you start moving data, someone wants to start looking at it. And so now you combine that with the fact that a lot of the developers are just human beings. They make mistakes. So when that happens, the problem today is that you have a really interesting problem occurring, is that people think that when a developer makes a mistake, well, that's their problem. But the thing is, it's always going to occur. So the question then is how do you actually start thinking about it to say, well, if someone is involved in a phishing exploit, or if someone hacks an edge device, how do you actually think about that? And how do you change the way in which you think about it so that you can address the problem, right? And so a lot of the stuff that I look at is the economics of the attack. Because today, if I have a cable modem, I have 400,000 devices deployed in a small area, and someone comes along and they can hack one of them. So the problem is if they can hack one of them, they can hack all of them. And now what you end up with is a very simple way for someone to take 200,000 devices and convert them from being a useful tool to being an object of use in an attack of denial of service against a larger business. Because this is the really interesting aspect of IoT. You have so many devices at the edge of the network, and they're very simple, so they can't contain a lot of security. And so when you start thinking of it that way, you have to start looking at it in a different light. And one of the things that that we look at is how do you make it more work for the attacker? And if you do that, you can simplify greatly the problem at the edge of the network. And it's not rocket science, which actually rocket science is inherently simple. But what it comes down to is that really what we're doing is looking for ways to put work onto the attacker so that the attacker has to do more effort in order to get a return on their investment. Because what I say about the edge of the network is that the reason why people attack it is because the return on investment is so high. If I attack one PC, that's great. But if I can attack 1 million PCs and I can co-opt them into a bot network, if I can do the same with the cable modems, it gets really interesting, because now I can control all the traffic going through the cable modem, and potentially I can do some other things with that. So I can redirect that traffic. Because one of the interesting bits is a lot of people don't understand is that the purpose of taking control of a device, or the purpose of watching someone or monitoring their PC or laptop, is ultimately they have to make money out of it. And there's a huge ecosystem that's been created to essentially steal information such as credit cards. But having the credit card is one thing, but now you have to figure out how to use it. And that's how they generate money from it. So what we look at, and what I'm particularly interested in, is how you actually move the work to the attacker from the defender. Because today, the defender only has to be right every day, and they have to be right 365 days a year. The attacker only has to be right once, right? And that's where you get into some really interesting conversations about how you could stop that. And so what I look at really is I say, look, you have to change the game. A lot of people think of security as a win-lose game, right? So I can win because I can stop you attacking, and you will lose. But the problem is it's actually an infinite game, because in an infinite game, people can join, leave, come back. They have certain prerequisites to the way in which they're playing the game and certain assumptions. But what that means is that you can never win, right? Under the current terms, what you have to do is change the rules of the game so that the effort to win the game is reduced. And that's what we do at Polyverse. In very simple terms, what we're looking at doing is saying, okay, the IoT devices are incredibly simple. They have very simple operating systems on them. And one of the points there is that the attacker can look at that very simple device. They find one exploit, and they can assume that that exploit, if it's a memory exploit, will work on all of those devices. And so what we do is we say, well, let's change the assumptions for the attacker, because if each of those devices or a set of devices has got a slightly different memory and register layout, we increase the work for the attacker. And that is one of the key components that we're looking at in addressing some of the edge security problems. Doesn't mean you solve all of them, but it solves one of the largest problems that exist around memory attacks.